Good afternoon. Are you able to hear my voice?
Yes, sir.
Yes, sir. Good afternoon.
Okay. And my PPT is
Yes, sir.
okay. Today, as we have discussed in the last lecture about a definition of DFT, IDFT, then we have discussed DFT as a linear transformation, and also we have solved the examples related to how to find a DFT of 4 point, DFT of 8 point, DFT of 5 point, like any point DFT we have calculated. So today we will discuss some of the important properties of DFT, the way how we have discussed the properties for Z transform and the properties for this Fourier transform. The same way we are also discussing here the properties of DFT. So let us see one by one properties. So if you look at into the properties list again, it's having around 8 to 10 properties. So some important properties I am going to explain now. So first we will discuss on the periodicity property. So the statement for this is, if you look at into the statement again, if you take a DFT of x of n, then we are getting the answer as x of k. Then if your time domain function is x of n plus n, then we will get it as x of n. Or if you have x of k plus n, then we will get the answer as x of k. So that is what we are calling it as periodicity. And hope in a signal sense system we have discussed a condition of periodicity. Periodic signal or a periodicity. What is the condition? Anybody? The condition for periodicity or for periodic signal in time domain signal. Yes? Can anyone give me the answer? बताएंगे? हेलो, आवाज आता है क्या मेरा?
As
Okay. So what is the condition of periodicity? X of t plus t0 equals to x of t. Whether we have studied on this part? Yes or no?
yes,
Okay, that is for a continuous time signal we have studied, and for it is a discrete time signal, we have a periodicity properties. Hope you are all writing the statements also. This first part you write it as a statement. If you take a DFT of x of n, then we are getting the answer as x of k. If we have x of n plus n equals to n, x of n, then x of k plus n equals to x of k. Let us prove this property. So first, in a proof, we are writing the formula of DFT. What is formula of DFT? कोई बताएंगे? So we have to start the proof with the definition of DFT. What is the formula? What is the formula? Formula of DFT.
X of k is equal to summation n is equal to 0 to n minus 1. X of n uh, omega n raised to kn.
Okay. So first write down that formula. X of k equals to summation n equals to 0 to n minus 1 x of n e power minus j 2 pi kn by n is our formula. Okay. Anjali, please stop your video. Then if you see the formula here, so what is the formula we are going to have is, so ये formula है आपका So in this, I need to substitute the value of, so first you write one line. Replace k by k plus n. Replace k by k plus n in above equation. K plus n in above equation. Then what will happen is, here the k value we are replacing. Just write this part. X of k plus n is equals to n equals to 0 to n minus 1. X of n will remain as it is. E power minus j 2 pi by n, and the value of k, I am replacing it by k plus n multiplied with n. Then if you simplify this, we'll get it as n equals to 0 to n minus 1 x of n e power minus j 2 pi n into e power minus j 2 pi by n kn. Understood how I am simplifying this?
Yes, sir.
In first part, n get cancels, so I have written it as e power minus j 2 pi n. Now what is the value of e power minus j 2 pi n? E power minus j 2 pi n can be written as, how it can be written? Just note down that e power minus j 2 pi n is equals to, कैसा लिख सकते हो उसको हम? Cos 2 pi n minus j sin 2 pi n बराबर. E power minus j theta can be expressed as cos theta minus j sin theta. Now what is its value? Value क्या आएगा उसका? कोई बताएंगे? What is the value? Anybody? For any value of n, what will be the value of this function? Cos 2 pi is what? Sanket Jagtap, you want to take a lecture? Stop your presenting. Stop your screen presenting. So what is the value? E power minus j 2 pi n का value क्या आएगा अभी?
1.
1 it is. So for any value of n, always the value of this e power minus j 2 pi n will be 1. You have to remember this forever, this complete chapter. Right. So now let us proceed further. So अभी क्या हुआ function? So this will be equals to, so this e power minus j 2 pi n will be 1. So I am going to write it as x of k plus n is equals to n equals to 0 to n minus 1 x of n e power minus j 2 pi n k n, which will be equals to what? This is again our definition of DFT. So we are adding it as x of k. So that is the proof. So what is the condition here? Now finally, the condition for periodicity property is x of k plus n, that is capital N, is equals to x of k. You may expect this as a MCQ question also. They will ask you like, what is the condition of periodicity in terms of frequency samples? So that is x of k plus n equals to x of k is the condition for periodicity. Now here you may ask me one question, sir. आपने दो फंक्शन लिखे x of n plus n equals to x of n, तो उसको कैसा प्रूव कर सकते हैं हम? Anybody? Which formula we have to use?
IDFT formula.
Yes, very good. By using IDFT formula, we can prove the above statement. So that is the task for you, right? Simply replace n by n plus n and simplify that. So you will get the answer x of n plus n equals to x of n. So this is what the first property. Or so with this we can note that, just note down that we can write x of k plus n equals to x of k. So with this property we can understand that the DFT is periodic with period n or simply this is known as the cyclic property of DFT. This is known as cyclical property of the DFT. Cyclical का meaning क्या है यहाँ पे? You all know the definition of periodicity. क्या definition है उसका? What is the definition of periodicity?
It repeats after certain interval.
The signal is going to repeat after some fixed interval of time. तो वो cycle repeat होते जा रहा है वहां पे. So after some interval of time, the cycle is repeating. If it is a 4 sample, so after every 4 sample, the signal is repeating. So that's why it's also called as a cyclical property of DFT. Understood? Any difficulty here?
No, sir.
So this is the first property. So you may expect these properties proofs also in the examination again. They will ask you like state and prove the periodicity property, 4 marks question. So there you have to write the statement as well as the proof again. Then let's move to the next property that is called as linearity property. अभी linearity property हम बहुत बार सीखे हैं. Like we have seen the linearity property in Z transform, linearity property in Fourier transform, and linearity property in systems also. क्या था वहां पे? Anybody? It is second property. We have it is linearity property. So can anyone tell me the statement of this? So many times we are repeating this. Meaning क्या है linearity property का? What is the meaning of linearity property? A27 is there? A27. कोमल जाधव. कोमल. Hello. Komal Jadhav is there? A27 absent. Komal Jadhav absent. A46. Omkar. Omkar.
Yes, sir.
Okay. Can you tell me the definition of linearity property?
No, sir. No.
Okay. Pallavi.
Yes, sir.
Can you tell me the definition of linearity?
Linearity means it can be graphically represented as a straight line.
Linear का meaning हुआ मैडम. Property of linearity. We have discussed that in Fourier transform, Fourier series, Z transform, हर जगह पे आ रहा है वो. So that's why I'm expecting the answer from you for that property. Pratiksha is there? Pratiksha Khobre.
Yes, sir.
आप बताएंगे मैडम?
Yes, sir.
Tell me the definition of linearity.
Sir, our A1 x1 of then E tends to x1 of z होगा और x2 of n tends to x2 of z होगा. तो x1 of n plus x2 of n is equal to x1 of z plus x2 of z.
Okay, so that is in terms of Z transform. Normally उसका meaning क्या है? The system which is satisfying a superposition principle, right? So this we are calling it as a linearity property. Either it may be in Z domain or it may be in uh, like frequency domain or it may be in again the time domain again. कुछ भी होने दो. So what is happening here is, so if you look at into the definition of this, and you please pass on this message, the names which I have taken, if they are not responding, I am directly putting them the absent. A 27 is absent for today's lecture. Komal, she is absent. Just intimate them who are all your friends. And this is not the proper way. Okay, so now intentionally I am doing that part. So if you are taking it so lightly, then I know how to handle like such situations also. So let us write down the proof. First write down the statement of linearity property. Is my slide is visible?
Yes, sir.
Yes, sir.
You just note down this property. If you take a DFT of x1 of n, then we are writing it as x1 of k. If you take a DFT of x2 of n, then we are writing it as x2 of k. Then we just note down that a1 x1 of n plus b x2 of n. If you take its DFT, we are writing it as k x1 of k plus b x2 of k. Then we are proving it with the same definition of DFT again. So any difficulty in this part?
No, sir.
Can I move further? Hello, am I audible? Okay, circular symmetries of a sequence. So as we have discussed already the definition of DFT and IDFT. If you take a periodic repetition of IDFT, then we are writing this in this format, like xp of n equals to L equals to minus infinity infinity x of n minus Ln. Then we can write a repetition or the relation between x of n and xp of n as x of n equals to xp of n for 0 less than or equals to n less than or equals to n minus 1 and is 0 otherwise. So what does it mean? Hello?
Sir, screen is not visible.
Screen is not visible? Okay. Now?
नाही sir. दिसत नाही.
आता येत आहे का? Hello?
Yes sir.
Yes, sir.
Whether it is visible now?
No, sir.
So दिसतंय.
Huh?
Yes, sir, visible.
Spin करा मग काय? You just spin on that my screen. Huh?
हा सर आता दिसते.
Okay. Now, we know the definition of DFT and IDFT. If you write a periodic repetition for the IDFT equation, then we are writing it as simply xp of n equals to L equals to minus infinity infinity x of n minus Ln. इसका मतलब क्या है कि यहाँ पे periodic repetition means the signal is having the value from minus infinity to plus infinity. But our definition is what? Definition of DFT is what? Whether it is finite or infinite. DFT are for return the definition as k equals to 0 to n minus 1 or n equals to 0 to n minus 1 we have written there. So then the relation we are writing it as x of n equals to xp of n for 0 less than or equals to n less than or equals to n minus 1 and is 0 otherwise, or else with this diagram we can understand very easily. So I have taken one small example x of n which is having the samples x of n is equals to, I have samples like 5, 4, 3 and 2. X of n equals to 5, 4, 3, 2. This is our x of n. Now, if you write its periodic repetition, इसका अगर periodic repetition लिख रहे, so then it will look like a second diagram which is having the value from minus infinity to plus infinity. अभी मुझे ये दोनों का अगर relation लिखना है, then what I will write? I will write x of n is equals to xp of n which is having the value from 0 to 3. Getting my point? Hello? Hello?
Yes, sir.
Are you able to understand this?
Yes sir.
Okay, note down this diagram as well as equation. Diagram is visible? Diagram दिसतोय का तुम्हाला?
हा सर.
Okay. So here just I have written the relation in x of n and xp of n. As x of n is our given sequence which is having the amplitude 5, 4, 3, 2 and we are writing the periodic repetition of that sequence. So which is as shown in the below diagram, that is xp of n. This is same as the way how we have done for frequency domain sampling. Or can I move to the
No,
next
sir.
part? Have you understood this part? So these equations already we have used in a definition of DFT and IDFT derivation. Hello.
Yes, sir.
Can I move to the next part?
Yes, sir.
Okay. So then next further what I will do is, so if I take it shifting of a signal, if I apply this, तो यहाँ पे क्या कर रहा हूँ? You just write down that let xp of n shifted by k units. Let xp of n shifted by k units to the right. To the right. Then we are representing it as x dash p of n. Then we are representing it as x dash p of n. So it's like this way. So x dash p of n equals to xp of n minus k, and our whole formula will be getting changed as L equals to minus infinity to infinity x of n minus k minus ln. So what you understood with this? Anybody? क्या मीनिंग है इसका? और
Yes, sir.
Vidya Dere is there? Vidya Dere. क्या लोग चालो करके क्या? I don't know whether they are sleeping or what. So what you understood with this? Can anyone tell me? Should I call with the numbers only now? So this way I have to go otherwise. Ankita is there? Ankita Sate. See the situation. Dhanraj Bhosle. Dhanraj Bhosle. Is my voice is audible? So I'm just checking who are all actively participating. Anchal Sheikh is there? Anchal Sheikh. Aisha Tamboli.
Yes, sir.
Okay. Can you tell me what you have understood with that presentation? क्या समझ में आया
In
आपको?
this time shift property is used.
Okay, time shift property is used. Very good. So that is what we are having here is simply xp of n minus k मतलब हम k वैल्यू से शिफ्ट कर रहे हैं. Suppose
Shift
if I
कर
take a
रहे
k,
हैं.
हाँ k equals to अगर 2 लिए, then that periodic repetition वाला जो सिग्नल है आपका ऊपर का xp of n, तो वो सिग्नल को राइट साइड को हम शिफ्ट कर रहे हैं. So then you are getting this signal. बराबर?
हाँ.
Okay, good. Then x dash of n equals to, we are writing the relation now, x dash of n equals to x dash p of n for, hello,
Screen is not visible, sir.
स्क्रीन कहाँ जा रहा है बार बार? Why it is getting now, whether it is visible?
Yes, sir.
Okay, so then we are writing the sequence like x dash of n equals to x dash p of n for the limit 0 to n minus 1. तो अब ये रिलेशन क्या हुआ आपका? After applying a time shift property to the periodic sequence, so we have got it as 0. At 0 we have the sample 3. पहला डायग्राम में आप देखो, at 1 it is 2, at 2 it is 5, at 3 it is 4. So this is how we are writing the relation again. Or else this we can write it as x dash of n equals to x of n minus k minus ln, or simply we are writing it as x of n minus k modulo n. Here the modulo n meaning is we are rotating the signal in n values, or in the rotating the signal in with the n times, right? Means we can express this function as x of modulo n minus k n. So this is how we are writing a circular symmetry of a sequence. The value is x dash of n equals to, we can write x of modulo n minus k n it is. So this is the expression which we are calling it as simply circular symmetry. Means if you rotate the signal, we will understand after the example again, like how we are rotating the signal and how it is repeating with the symmetric values. Okay. Can I move to the next part?
We are drawing the signal, sir. Wait.
Okay. Or
Yes, sir.
okay. Now let me move to the further part. So here so x dash of n equals to x of modulo n minus k n. Now if you take x dash of n with k equals to 2, as the shifting value we have taken it as k equals to 2, then n equals to 4. In that case, we are writing the equation as, you please note down these equations. X dash of n is equals to, we have it is x of modulo n minus 2, 4. Okay. Now if I take n equals to 0, 1, 2, 3, then we will write x dash of 0 is equals to x of modulo n is 0. Hello? Any difficulty? Same slide दिसतंय का? Hello?
Yes, sir.
This slide is visible now.
Yes, sir.
Okay. Now let us so x dash of n equals to x of n minus k. If I take k equals to 2 and n equals to 4, then what's happening here is, just note down this, x dash of n equals to x of modulo n minus 2. The value of n is 4 again. X dash of 0 is equals to x of minus 2, 4. The value will be equals to, what we will write? It is x of 2, which will be equals to, we are writing it as simply x of 2. Getting my point? Why it is x of 2 I am writing? X dash of 0 equals to x of modulo 0 minus 2, it is minus 2 with 4. So 4 minus 2 we are writing. 4 minus 2 is x of 2. What is value of x of 2? कोई बताएंगे मुझे? x of 2 का वैल्यू क्या था यहाँ पे? Hello? Hello?
Yes, sir.
What is the value of x of 2?
5.
According to the diagram. No, it's not 5. It is 5, 4, 3, 2 is there, na? 0, 1, 2, 3. The x of 2 is 3. Okay. Then next, if I take x dash of 1, which will be equals to, so what I will write? X dash of 1 equals to x of modulo 1 minus 2, 4, which will be equals to x of modulo minus 1. तो आंसर क्या आएगा इसका? हेलो, what is the answer? Are you able to hear my voice?
Yes, sir. Can you explain it once again?
Okay. So what I'm telling is simply, have you noted these equations?
Yes, sir.
Okay. So x dash of n equals to x of modulo n minus 2, 4 is there. So we are now changing this value of small n. तो मैंने क्या लिखा अभी? x dash of 0 is equals to x of, actually it is modulo, right? It's modulo value in it, right? x of modulo minus 2, 4, double bracket लिखो वहां पे, is equals to this, as 4 is n, so 4 minus 2, तो क्या हुआ value? x of 2. Understood? Hello?
Yes, sir.
Similarly, x dash of 1 है यहाँ पे, तो यहाँ पे क्या हुआ अभी? x of modulo लिखो, डबल ब्रैकेट लिखो उसको, एक ब्रैकेट मिस है वहां पे, जस्ट राइट एज ए डबल ब्रैकेट, minus 1 आया अभी, like 1 minus 2, the value is minus 1, as the value of n is 4 again, so it is 4. So we are adding it as x of 3. ठीक है? x of 3 का वैल्यू क्या है आपका? What is value of x of 3? Is 2. ठीक है? Then x dash of 2 is equals to, क्या लिखा मैंने यहाँ पे? x dash of 2 equals to, if you take n equals to 2 here, so 2 minus 2, 0 आया. So x of modulo 0, 4. क्या हुआ यहाँ पे अभी? This is very important point to remember again here. So x dash of 2 is equals to, what's happening? X of modulo 0, 4, which equals to, is writing it as, actually x of 4 है, right? Whether x of 4 value is there in our given sequence? Hello? Can anyone tell me the answer? Is x of 4 is present in the given sequence? Hello?
Yes, sir.
x of 4 का वैल्यू प्रेजेंट है क्या? Just look at into the diagram. First sequence, what it is given. It is there or no? Hmm? So it is, the samples are given as 0, 1, 2, 3. So 4 का value present नहीं है वहाँ पे. Then what is happening? It is repeating this value again, right? So 0 का value 4 पे आ रहा है. So I am just writing it as x of 4 equals to x of 0. That is x of 4 will be equals to again x of 0, which has the value of 5, right? And then lastly we will write it as x dash of 3 is equals to x dash of 3 equals to what we will write, x of modulo 1 with 4. तो वैल्यू क्या आएगा अभी, x of 5 आएगा. Is that value is present?
सर कुछ भी समझ में नहीं आ रहा है.
हाँ सर.
Okay.
सर पेन आणि पेपर
Have you understood this equation? पेन आणि पेपर घ्यायचं का आता? Okay. So let me see. Okay. Now what I have written is x dash of n is equals to x of modulo n minus k n. ये लिखे हमने इक्वेशन.
पीपीटी ही दिख रहा है सर.
पीपीटी ही दिख रहा है क्या उधर? Okay. So I will stop this video. Hello?
Yes sir.
Is it visible now what I have written?
No, sir.
No sir.
Oh. So we are writing it is x dash of n is equals to x of modulo n minus k n. दिख रहा है अभी?
नहीं सर. नहीं दिख रहा है सर.
Okay. Okay, 1 minute. Now whether it is visible?
No sir, it is blur.
It is blur. आता काय करायचं याला? Mobile. Blur this thing. Okay, whether it is visible now?
Yes, sir.
Okay, x dash of n equals to x of modulo n minus kn. Here I am just changing the value of n. N equals to, we are writing it is 0, 1, 2, 3. Okay. Ulta is right. Yeah, bhai. Ulta is. Okay, we'll stop it here. Further, I will continue again.
Okay, sir.
We'll continue next again. Just please mark your attendance.